one of the first articles of yours that fascinated me, and one of the reasons I first reached out, was you had an article about, I think it was about 100 million years after the Big Bang, that the temperature, was somewhere between, the unimaginably high temperature at the beginning and the now hard to imagine for humans, the low temperature of the universe today. It was around room temperature,
Yeah, I can bring the exact number. So that was true. The universe was at room temperature actually 15 million years after the Big Bang, just before the first stars formed. But one thing to keep in mind is, on Titan, the moon of Saturn, the temperature is a third of room temperature. It's about 94 degrees. And the universe had that temperature after the first stars formed. So there is liquid methane and ethane on Titan, and potentially, there could be chemistry that could lead to life in that liquid. And so, the question is whether, as soon as the temperature in the universe reached those values that allow liquids to exist, so you can have chemistry in liquids, and obviously after the first stars formed, so you have heavy elements, could that have been the beginning of life as we know it?
Yeah, I think that once you get below a certain temperature, there's a huge diversity of environments and once you get the elements and temperatures can vary all over the place at that point. And I wouldn't want to be so chauvinistic to think that the particular biology we have now is the only one, but certainly I don't think it's too chauvinistic to say we need reasonable temperatures and elements. That said, one of the big issues with the Drake equation is just how long does it take to make something, some of the so-called simple things in molecular biology. So, we have theories like, RNA world, where you can do some kind of replication with just say lipids and short RNA molecules that all they do is replicate in some very primitive metabolism.